Hello everybody, welcome back to another video on the Interstellar Traveler channel here, and in today's video we're going to be looking at some wacky planets. Not planets, exoplanets. What are exoplanets? Exoplanets are planets that are outside our solar system. So we're going to be looking at some very wacky exoplanets that you will probably die in. So now right in front of me is the star J1407. Now what is interesting about this star? Well, it has a planet called J1407b. Let's go to this planet. Now, let's just back out here for a second. Do you notice the ring system of this planet? Well, it's pretty big. In fact, this is so big that that if this planet were in this place of Saturn in the night sky, it would look as big as the moon. Now, this is a gas giant, much like Jupiter and Saturn, and it is in fact an even bigger gas giant than Jupiter. But we have never actually seen this planet, but we know it has a big ring system. How is this the case? Well, while observing the parent star, they noticed that the star kept on shrinking and it kept on losing light and emitting light at the same time. The scientists who were part of the project were very curious as to how this planet was overlapping its parent star like this. Now, if you don't know what I'm saying right here, a common method we use to find exoplanets is called the transit method. So when a star is shining bright and then for a short period of time it starts losing its brightness, we can say with certainty that this was certainly an exoplanet. Now, when they were observing this star, they noticed that it kept on losing brightness and kept on getting brightness back and kept on losing brightness again. So the only possible explanation for this was A, this is a ridiculously huge planet, or B, this is a planet with a huge ring system. And the second option seems more feasible than the first option, because there is no way a planet can be so big, it's bigger than its own pair. It's bigger. It's what do you call it? It can dim out its planet's brightness like this by itself without a ring system. So we came to the conclusion that this is a ring system. And in fact, and this is not the most impressive part. This planet itself is bigger if we remove the ring system, which I can't do. But if we go to this planet, it's actually bigger than Jupiter and Saturn. So as you can see here, this is the planet. Let's go inside it. Wow. See this. So this is a gas giant. It doesn't actually have a solid system. Doesn't have a solid land in it. So this is a very inaccurate representation of what the planet would look like, because you just keep descending or you would crush yourself to death. So that's the first wacky planet, guys, J1407b. Why am I saying guys? Next planet is an exoplanet that reflects such little light you can barely see it. And this planet is called Tres 2b. Now, it's again, many of these planets are not represented correctly here in Space Engine, but Tres 2b was discovered was discovered not that long back. But the thing about Tres 2b that's really interesting is the fact that, oh wow, sorry guys, 1 second. The thing that's very interesting about Tres 2b is that it reflects around 0.2% of the light that that is given to it by its host star, and it absorbs the rest of the light. And because its atmosphere is mostly red in color, you can see it with black and a glowing menacing red. So this is basically the least bright planet in that we know of currently. Okay, so now we're gonna look at a less wacky planet, and we're gonna go to one that is actually maybe could harness life. And this planet is Trappist 1e. Wait, when we go to the Trappist star system, we find this planet. Let's go to the Trappist star system. Okay, so Trappist 1e. In fact, Trappist 1e is not the only planet that could harness life. It is in fact, wait a minute, why is everything so bright? Oh, that's why. So basically, here's the planet TRAPPIST-1e. Now, this planet doesn't look like Earth by any means because this is space engine, but we think that it is very, very much similar to Earth. How can we say this? Well, there is actually a metric that is used to check how Earth-like a planet is, and this metric is called the ESI, the Earth Similarity Index. The Earth Similarity Index is the Earth Similarity Index is scored out of 1 or 100%. The planet with the highest ESI is of course Earth, and Earth has an ESI of 100% or 1.00. TRAPPIST-1e has an ESI of 0.735, meaning 73.5%. So this looks like a very likely candidate for life in the future. However, this is not the most Earth-like planet in this star system. If we go to TRAPPIST-1f, oh no, wait, not TRAPPIST-1, TRAPPIST-1d, it has an ESI even higher than that of TRAPPIST-1e, 74.6%. Now, I would like to apologize for the way these planets are conveyed, but the planets do not look like this at all. They possibly have water, and they possibly have much more life-bearing conditions than the way they are portrayed in this game. But just look at these views, man. So, according to the game here, Space Engine, this has a huge atmosphere, this planet, and it has a lot of mountains, and it's a rocky area. But this is probably not the case. In real life, it probably has an atmosphere similar to that of Earth, and it probably is a little less mountainous than portrayed in the game. But still, we should take a minute to appreciate how these rocks look like. In fact, these mountains bear similar resemblance to the mountains at a national park in China. They are colored and stuff. So this looks exact. This looks very similar to that national park in China. If you know what I'm saying, you'll understand. If you know what I'm saying, you know. Look at this. And according to the game, the planet has an atmosphere mostly comprised of carbon dioxide, but uh, this is probably not the case. It probably has some oxygen in there as well. And the greenhouse effect is not as drastic as portrayed in the game, 16 degrees. This is definitely not the case. This is again, this game just basically generates the climate accordingly, but this is very much an Earth-like planet. Now, we can go to one more planet which has a very good ESI, and that's TRAPPIST-1c. This is the most Earth-like planet we know in this TRAPPIST star system. It has a 92% ESI, which is very, very good. It is portrayed as just a bunch of ocean, but this is definitely not the case. It definitely might have some land because it's an Earth-like planet, and this is a 92.7%, meaning this is a very, very much an Earth-like planet. And now we're gonna go to one more planet. And what's this planet called? Okay, now let's go to Proxima b. Now this is actually not far from our own solar system. This is in the Proxima Centauri system, and the Proxima Centauri system is just 4 light years away from Earth. Now again, this is not portrayed accurately in Space Engine. Proxima b actually has an ESI of 0.85, meaning it has an 85% similarity to Earth. I got so scared right there. So this is portrayed as not a very Earth-like planet, but this is definitely an Earth-like planet over here. It has two theorized gas giants in Proxima C and Proxima D, but the only confirmed planet we know of in the system is Proxima B, and it has very high signs of Earth. It has very Earth-like properties. Now we can go to the next planet, Tau Ceti E. This is also not far, this is around 6 to 7 light years away from Earth, the parent star Tau Ceti. And again, this is portrayed as a Neptune-like planet, but this is not a Neptune-like planet at all. In real life, it has an ESI of 0.8%. So, not 0.8%. Sorry, that was a huge mistake. It's around 80.8%. So this is 80% similar to Earth, and the game portrays this as a Neptune, but it's definitely not the case. It is in fact much more life-bearing than a Neptune. Okay, now we're gonna go to the next wacky planet over here, and now this next one over here. We're gonna. In fact, I don't think we should go to any more planets. Now we're gonna look at one wacky object over here. We're gonna look at one more wacky. Okay, you know what? Let's go to one more wacky planet, Mercury. You must be thinking, wait a minute, what's in Mercury that makes it so wacky? We all know Mercury. It's the first planet in the solar system. Well, let me tell you what's so wacky about Mercury. Let me tell you what's in Mercury. Now, I'm just going to land on Mercury and sort of tell you in this way. Now, the thing about Mercury is that it is very it the a day on Mercury is longer than a year. Meaning, sorry, the day on Mercury is longer than a year. Meaning, it rotates around itself faster, but it takes less time to rotate around the sun, revolve around the sun. So in this way, a day is essentially longer than a year. This part about Mercury, when I talk to people about wacky planets, they always tell me trust 2b and tau, what do you call, J1407b and HD 146, one more planet, which I forgot the numberings, but it starts with HD, and it rotates around 650 astronomical units away from its host star, which is very long, by the way. What's an astronomical unit is the distance from the Earth to the Sun. But they've always failed to mention Mercury, and this fact really saddens me because Mercury is a wacky planet in its own right. Imagine living on a planet which has a day longer than the year. Mostly a year is longer than a day. A year on Earth is 365 days, 365 days, but a day on Earth is just 24 hours, or more precisely 23 hours and 56 minutes. However, on Mercury, we have this we have the weird thing that a day is longer than a year, meaning it takes less time to rotate around itself than it does to revolve around. It takes more time to rotate around itself than to revolve around the sun, which is very weird. I mean, the fact that it takes so much time to rotate around itself is pretty weird, but the fact that it revolves around the sun this fast is not a shocker because it's really close to the sun. So it will of course rotate around the sun pretty fast. But the fact that it takes less time for it to rotate around the sun rather to revolve around the sun rather to rotate on its axis is kind of weird. So that's it for today's Wacky Planets. I hope you liked this episode of Wacky Planets, and I'll see you in the next video.